Imagine crossing endless ice fields where temperatures crash to -40 and winds scream past 200 kilometers an hour. This is Antarctica, one of the most hostile places on Earth, where untouched ice preserves a time capsule of Earth's climate history, just waiting to be researched. To confront climate change, we must study nature where it's still untouched. But today's research depends on massive, fuel-hungry machines, expensive, polluting and impacting the very environment that needs to be researched and protected. This is exactly why Team Polar, a group of students from the Technical University of Eindhoven, are developing an autonomous vehicle to make research more sustainable, affordable and efficient. Welcome to our new episode of Road to Antarctica, and this isn't just any episode. Over the next few days, we're going to be joining Team Polar in Swedish Lapland. For the very first time, Gentoo, their prototype rover, will touch snow. This will take the team one step closer to their goal and ultimate destination, making research on climate change in Antarctica more effective, sustainable and safer.
One of the cables is... It's not frozen in at least.
Join me as we witness this student team pushing the boundaries of innovation here in Sweden. So I'm just about to drive over a lake on the way to see Team Polar at the Ice Makers, which is an automotive proving ground in Lapland, where normally you'll see like BMW cars and Mercedes driving around to see how they react in the snow. But Team Polar are here to see how their rover works in the low temperatures and in the snow, see what they can break and learn on their way to Antarctica. Really excited to see how it goes today. The team working on the rover is made up of students from many different fields of study. The morning stand-up meeting is important to find out what the priorities are and who needs to work on what so they can start testing as soon as possible. The expedition is short and there is no time to lose.
Okay guys, the plan for today is to conduct these 4 tests on the board. The traction test, turning radius test, crevasse traversability test and obstacle traversability test. These have to be completed, and before we do that, we need to solve the following issues that are on the board. So everyone available, hands on deck, start solving one of these and coordinate with responsible people. Today is gonna be a great day. I'm glad you're all here at 9 a.m. and let's get to it. Okay, vamos.
The workshop is a hive of activity and tensions run high as the team focuses on last-minute preparations and problem solving. I feel like I'm getting in the way, so I take a walk to chat with team manager Doruk to find out more about the team. So you're a big team, loads of students, loads of different degrees and from all over the world. How do you collaborate together?
We have a lot of perspectives, we need a lot of perspectives. The challenges that we are tackling need different insights. For example, we have our battery people, we have our autonomous people, we have our mechanical people. These all have to come together, and that's what we are trying to achieve.
What do you think of this as like a learning experience for everyone?
It's an amazing experience for everyone, not just for the engineers, but you can learn everything that you need. Just being here in this white environment, this is also something. We learn about mission planning, we learn about actual engineering, we learn about operations. This is an excellent environment for you to actually learn, for you to gather information.
It's not just about running preset tests, it's also improvising. It's like travelling to the moon and forgetting to bring a piece of equipment with you.
I don't have any glasses other than sunglasses, so as you can see, a lot of sun.
We want to see if all the designs work, if they break down, if they behave according to our calculations, and collect as much data as possible. That's the biggest goals of the trip.
And then I guess when you get back to Eindhoven, right, you're going to have some kind of design reviews and you're going to do a new digital design and then a new physical design. And what's the kind of short-term and long-term goals that you've got?
Well, we have to do a lot of planning again. We want to have another trip by the end of the year. exactly how you described. We're going to design again, then we're going to test again, and we're going to validate again. In the meantime, we also have to think about the future, the long-term future ahead as well. And that's where TNO is helping us with the strategy tools that we need for the long-term planning. What happens before Antarctica, what happens after Antarctica. These are some tools that TNO is going to provide us, the strategy workstation.
To survive extreme cold and wind, the rover must be more than just intelligent. It must be precisely engineered to keep moving, sensing and navigating through the harsh environment. The result is a 300 kilogram rover with 6 square meters of solar panels, an insulated battery and full autonomous operation 24/7 at an average speed of 3 kilometers an hour. Now, let's dive into some technical details on how the battery, solar panels, autonomous system and tyre have been designed. How do you know, though, how many panels you're going to need on your actual rover when you're in Antarctica?
There is a solar yield model, which essentially entails, according to irradiance data and the geometry of the shape and the time, how much solar energy you'll be getting. We have the Big Eye model from TNO. We didn't know how much energy we'll be getting with the surface area, then that would impact like what motors we could take, because if we're in no capacity generating that much power, then you want to go for smaller motors. Some other things, for example, that really impacted our design decisions is if you have the shell, you would expect the top part of it to be the most effective one, like the ones that are generating the most energy, but that is not the case. It's actually at an angle of more or less 70 degrees that it generates the most amount of energy, and this we got from solar yield models.
I guess the actual real reason for the difference between these two is that in theory nothing is going to stick to this, right? Whereas
Yes.
on this one you're going to get,
Yeah,
straight away you can see the difference. Even
I mean, like it's like you can see that the impact immediately plummets, and here
it's still sticking more on this side than it is comparatively on this side. What do you need to do still before you go to Antarctica?
So modeling of the thermal behavior of the cells was quite important. From that we also got help from TNO with cell characterization, and our contact Alessio really also gave us some lectures and workshops on how batteries behave, especially lithium-ion batteries, which is quite useful.
As the team rushes to fix last-minute problems and get the rover out in the snow, we go to explore where the rover will be tested.
Second gear and you need to speed up. No, it's fine.
Reaching it isn't easy. Test track ahead is a challenge itself. And how similar is this to Antarctica? Is it similar-ish or is it quite different?
If the snow is gone, it's quite similar, but
yeah, I
with
mean,
the
this
snow
is
it's
even
different.
less compact probably what we're gonna face in Antarctica, since like minus temperatures, and we're gonna be traversing on like a, let's say, clear, like in a way, path.
And how long was your journey to get to Lapland? About 2,000 kilometers?
2.6.
2.6.
That's a long drive.
Yeah, divided up to 3 days.
But the last day was a tough one. The last day,
Because on paper it was 10.5 hours, and kilometer-wise, I think it was around the same as it was for the first day, but well, around 300 kilometers before coming here to Arjeplog.
even more, I think.
We stopped seeing the color black on the road.
Oh yes.
So we also had to. Some of us come from, let's say, northern parts of Europe, so we do have some experience driving on the snow. But for some people, it was also an opportunity to learn, and they had to learn fast. Yeah, but it's for sure a non-stop learning curve, because these things that we couldn't really anticipate also occur on every step we take, and hopefully we can deal with them as soon as possible. Right now, scientists every year go to Antarctica every summer to research and learn more about our Earth. They do it because they care about climate change. They want to basically explore the ginormous time capsule that the Antarctica and the ices of Antarctica hold. But to do so, they are flying using ships and using kerosene. Kerosene that is basically polluting the very pure environment that the Antarctica holds. So our mission by coming here is to test the mechanical design that we've been working for the last year and developing, building, spending multiple hours in the workshop to prove that this logistics can be done without kerosene and can be done in a sustainable way. That's why we hope that this trip proves that the mechanical design is valid, and it will enable us to traverse in Antarctica.
Autonomous driving is pretty much revolves around sensor fusion. So we are working with a LiDAR, we are working with a depth camera, and also so those are the perception, the vision of the robot, and we are currently working on fusing those two together. This is a recording of the LiDAR's perception in the workshop. I took it last night.
Oh yeah, so I can see the people walking around.
Yes,
you can actually see the difference between the wall and the door.
Absolutely, yes. It's quite likely that even you guys are here somewhere.
Huh? Can we zoom in at all, or is that?
Absolutely, you can do whatever you want. You can zoom in as close as possible. So essentially, you can see that, for example, this is where we work. We are working with software that takes in point clouds and essentially is able to calculate these slopes and map the whole environment. And instead of just having a 2D cost map, which is like which says obstacle, no obstacle, here we work with way, let's say, complex logic, which is exactly calculating the slopes. Based on the slopes and roughness, we can estimate the traversability of this particular point, and then based on that, finally we create the final cost map and navigate within that.
One of the special developments that Team Polar have been working on is a 3D printed airless tyre, which I'm really interested to find out more about. So this is the first actual full-size prototype of the wheel and tyre, right?
Absolutely correct, yes. We have brought this tyre along with us to testing trip 1, and we have made some new innovations, some changes. First and foremost, we've really switched from a linear design to a more pneumatic tyre-like design. So over here we have this flower petal design in the airless tyre, and each petal we've now made it so that each hair of the petal becomes gradually thicker, essentially stimulating this.
Yeah, so the base here is thick and then it gets thinner up to the top.
Up to the top,
yeah.
Exactly.
So it's the first bit of travel is softer, yeah, and then it gets harder.
And then it gets stiffer
down.
and stiffer, which is really what it is like with a typical air tyre. Our first and foremost objective is to maximize reliability. So a little bit of weight gain for reliability is deemed an okay exchange.
Because at the moment, I guess it's interesting, right, to see this in the full scale when you've got the small one running at TNO at the moment in the low temperature chamber, to see how reliable it is at scale. So it's good to see it in real life in full size. I want to try and roll it in the snow and see.
Absolutely, please do.
The days are short and the expedition is limited. Everyone is working round the clock to make sure testing time is maximised. There are a number of cable connections that are not holding up well in the current conditions and for which a creative solution has to be found. Without these cable connections, the rover will not run.
Okay, we got this,
Just in time, they managed to get the rover ready for the ultimate test. After years of design, months of preparation, and days travelling up here, for the first time Gentoo rolls out into the snow. Finally it's time to see if everything performs as required. Everything is going well, and straight away the rover conquers an incline even steeper than what it was designed for. The next question mark is how will the 3D printed airless tyre perform? Will the tyre developed over the last months prove itself?
Well, it's going to be very difficult to let this go. I mean, look at this. This is an amazing place. The Team Polar is an amazing place. I'm really enjoying this. But I'm planning on graduating by the end of this year. What I want for myself is to have actual impact in this world and leave my mark in a good way. Solve some problems, tackle some interesting challenges. That's what I want to do. That's what Team Polar does as well.
Exactly, I was going to say, I think you're already making a mark and leaving an impact in the world with what you're doing now.
Yeah, I hope so, in a good way.
Yeah, definitely. After all of these successes and learning moments, it's sadly time for me to go. It's been great to be a part of this amazing mission. What a great journey it's been here in Sweden. It's been wonderful to see Gentoo hit the snow for the first time and to see Team Polar learning and iterating and getting all this data so that they can go and improve the rover. It's just one step in their journey to Antarctica, and there's going to be loads more, so join us for the next episode soon.